Module 5. In Module 5, we will discuss the improve phase. Now, the Module 5, that is improve phase, starts off with another round of brainstorming. Now, there is a difference, technical difference between the brainstorming session that we do in the analyze phase and the brainstorming that we do in the improve phase. In the analyze phase, the brainstorming session or the brainstorming technique that we apply, we explore the root causes of the problem. And in the improve phase, we explore the solution ideas to the problem. Other than this, the do's and don'ts, the way of conducting a brainstorming session exactly remains the same. In the analyze phase, whatever root causes you have received, based on this, all the improvement solutions you have to explore. Now, after you are done with your brainstorming session, whatever improvement solutions that you and your team have finalized, based on this, you have to do two very important plans. The first one is the improvement plan. The improvement plan will basically jot down the total details of the improvement that you are going to do, how it has to be done, how it is to be completed, how it is to be executed, the details. It has to be very much in detail so that by looking at that documentation, anyone within the team will be able to do the improvement. After the improvement plan is done for all the improvements, the next plan that we suggest to do is the implementation plan. That is, after an improvement is completed, how it is to be implemented. So it will be definitely a smaller documentation with the implementation steps as applicable, as required. This is one sample improvement plan, one sample implementation plan. And in the course of implementation, if you feel that something you need to pilot, that is to try out in a small scale before you do the full scope implementation, that also you can do. In the course of improvement and implementation plan, whenever you want to do the improvement and the implementation plan, in addition to each and every improvement and each and every implementation, you have to conduct another very, very important plan, which is called a risk management plan. Now, this risk management is mentioned as per different names in different sectors. Manufacturing organizations, they call it FMEA, failure mode effect analysis. Nowadays, we see in various sectors, we have risk being done with various ways, in various ways. Risk management plan, risk analysis report, risk management report, risk repository, risk report, whatever name you call it. So for each and every improvement and each and every implementation, you have to do a risk management plan. And there are 6 steps of doing a proper risk management plan. Identify the risk. Step number 2, identify the risk priority number, which is the risk quantification, which is done with the help of 3 factors: severity of the risk, occurrence probability of the risk, and risk detection. Based on this, ideally, the severity, occurrence, and detection has to be rated in a range of 1 to 10, where 8, 9, 10 are the highest severe, highest occurrence, or highest detection rating. Okay? So, ideally, a severity, occurrence, or detection rating of a risk should be each 10, 10, 10. Maximum it can happen. So an RPN in that way will be 10 into 10 into 10, which is 1,000. So in your risk register, if you have a risk which is having an RPN which is equal to 1,000, it means that is the highest risk. So it has to be closed as early as possible. Remember, any risk that has come up in a risk register, you cannot ideally keep it open for long, because if you keep a risk open for long, what is a risk? Risk is something which is uncertain, which might happen. And if it happens, it becomes a problem. So we have to understand that the risk has to be closed at the earliest possible, as early as possible. So this is the risk priority number. Third step is identify the mitigation plan or action, how you want to close that risk. And fourth one, identify the responsible person within the team who will close the risk and the target date of closure. And identify re-evaluation. Whenever you set to change or alter the RPN number because of the severity, occurrence, or detection likelihood has changed. Accordingly, you can change the RPN number, or whenever you feel a risk has been closed, it does not exist any longer. That is also risk evaluation. Out of this severity, occurrence, and detection, always remember severity is the most important factor that you have to consider. Now, if there are three risks in the risk register, all three having the same RPN, any out of these three, if anyone is having the highest severity rating, that has to be handled first. Okay. So severity, if it is very, very important and urgent, and if it happens, it can bring showstopper in the organization. Second one is the occurrence probability, how quick it can happen, how frequent it can happen, and detection likelihood. If a risk is not detectable easily in open eye, it needs some introspection, inspection, audit, then only we can detect a risk that is should be having the highest rating. This is one sample of an FMEA form that we have, the risk management register. 7 management tools. Now we have discussed about the improvement plan, but there are few management decisions that we can take before we actually try out with the improvement plan. So before finalizing on the improvement plan, some of these techniques we can apply before finalizing the improvement plan. One of them is application of a 7 management tool. Affinity diagram is the first one. Otherwise also called the KJ method, it is used to organize many ideas or decision criteria into groups based on their underlying relationships and affinity. Affinity means likeness. This method is used when the team is confronted with a large number of different ideas or solutions, and if the issue seems to be very complex and difficult to manage, then they break it up, identifying the similarities. Relationship diagram. This is also called as the interrelationship diagram. It is used to signify the strength of relationship between two processes or entities. It helps us to understand the causal relationship between variables or processes in a complex scenario. It establishes the linkages between variables and processes. The number of incoming and outgoing links indicates the importance of each process. The higher number of incoming arrows indicates that the higher dependency of that process on other processes. Similarly, the greater number of outgoing arrows from a process indicates the importance of that process on other dependent processes. Tree diagram. This helps in understanding the process level by breaking down complex process to the minute level of detail. This is a very good practice, I will say. It helps the team move down from broad process map to specific process details and requirements. It brings down and explores the finer details in any complex process. This is very helpful in decision making in a complex process with many business rules or in process that have huge financial implications. Prioritization matrix. This is the tool that helps in prioritizing an option over others, given a set of decisions making criteria. Options and criteria could be arranged in whatever row or column format. Weightages are assigned to each criteria, and each team member must rate each option on all the criteria. Based on the rankings, the option that has the highest rating or weightage collectively on all criteria are ultimately chosen. Matrix diagram. This is another tool that helps in establishing relationship between variables. Variables are arranged in, it could be arranged in row and column in a diagram. and the strength of the relationship between each pair is marked in their corresponding scale. We can use this to measure relationship for one, two, three, and four sets of variables. First, I will talk about activity network diagram. This is also called as an arrow diagram and is used by project management professionals to map their activities and sequential tasks in a visual format to understand the optimize the project duration. Plotting the diagram makes you find the project duration, schedule tasks easily, and identify the critical path. Process Decision Program Chart, PEPC. My simple answer, you need not do it because this basically talks about in the course of implementation or improvement mainly, what are the risks that you are facing and how you manage. For this, you have already discussed about FMEA and the risk management register. So that suffice. Theory of constraints means before this is another area which a management can take a decision on before coming out with a improvement plan or finalizing on an improvement plan. Before coming out with an improvement plan, let us consider first what are the constraints we have. Many organizations have country level constraints, province level constraints, state level constraints, industry level constraints. So let us jot down those constraints first, and then whatever improvement we envisage, then we can do first consider all those constraints and then come out with an improvement where there are no constraints and can be activated and done free. Trees, theory of inventive techniques. In order to discuss theory of inventive techniques, I will discuss four steps. First of all, in your organization, try to identify what are the problem in your process. Then, with the help of the benchmarking methodology, mainly the competitive benchmarking, try to understand globally similar kind of organizations, whether they also are having the similar conceptual problems or not. If yes, how do they handle that? Try to understand their process. It is not necessary that you will be able to ditto follow those process, but at least you can have an idea and mold your process accordingly, and that leads to your final solution. Scamper technique. Scamper technique talks about seven areas of updating a process or consideration before you come out with a updated improvement. Substitution, any process which could be substituted. Combining, if there are two or three processes which could be combined together to make the process work better, that can be done. What are the adaptability? Adjust to a new purpose, adjust to a new process by the organization, modify, magnify, minify, that is, enhance the process as required, if make it short if required, and modify as applicable. Put to another use. If there is already a process which has worked good for other areas, don't totally discard it. Better use it in another process which will definitely make some value added contribution. Eliminate. Eliminate means simply delete a process which is not going to really help. Rearrange and reverse. Rearrangement. Originally, you had a process set up like first you do step number 1, 2, 3, 4, 5. Now, after improvement, you can also do 1, 3, 4, 2, 5. So this way you can rearrange your process as the process flows. SMED, single minute exchange of dice. Single minute exchange of dice. To explain this, I will go through these two pictures. The picture at the top, what it shows this gentleman is changing the tire of the car where the car is completely in a standstill mode. Engine stopped, the car is completely stopped. After the tire is done, the person has to start the car again and then drive. But in case of a motor rally below, if you see, I am not sure how many of you have noticed how motor rally tires are also changed. That time the tires are changed, the engine does not stop. The engine keeps on moving. So when the tire has been changed, the car picks up the speed immediately and runs. So which one is faster? Obviously the latest one, the lower one, that is the SMED mode of work in a machine. This is mostly applicable in manufacturing organization. The idea is what changes to the machine could be done when the machine is completely in the running mode. You don't need to stop that. So you can do the changes or add something to the machine when the machine is still running. So there is no, what I would say, pause in the production or certain areas where the machine has to be completely stopped. And then only you have to do these changes. So of course, the machine, it is not stopped. That is the best thing to be done. The next area we discuss is a solution selection matrix. Especially, I would expect that the black belt does this solution selection matrix in an organization whenever it is necessary. We will discuss on the table on the right hand side. First, I will come to cost impact. Any improvement to the process which you do, which is having a bigger cost impact. For that, you need to have a sanction from the organization. So a cost impact, if not properly approved by the organization, could also have an impact on the sigma, that is the process capability. Because if you originally have planned, say you have targeted that I will reach a 5 sigma level, but as because some of the cost has been compromised to an extent, it can happen that you have reached finally 4.25 sigma, which is also okay, provided you have to see whether the upper and the lower specification limits or the CTQ has been achieved or not. That is the final goal. If that is achieved, a little exception to achieving the sigma level is perfectly okay. At least 2 or 2.5 sigma higher you should reach compared to the major phase sigma impact. So cost impact has an impact on the sigma also. Same with the time impact. If there are 10 improvements that you are doing, and out of this, 5 improvements, out of them, maybe 9 improvements are well done on time. Only one is a bigger one which needs some additional time, which maybe the customer is not agreeing. In that case, what happens? It also could have an impact on the total improvement that you are trying to make. But you have to ensure whether the USL, LSL are getting achieved or the CTQ are getting achieved or not. If that, you have to push back. Else, if it is still there that the USL LSL is still getting achieved, no issues, only it might have some impact on the sigma, which is okay, provided you reach at least 2 or 2.5 sigma higher. Other impact, we don't want to discuss it over here. Other impact also talks about the risks related to this impact thing. So which we are already taking care of during our FMEA or the risk management plan. Before and after scenario, after your process has been improved, with the improved data, you have to come out with a revised process capability, recalculating the sigma level now, which definitely should show a much improvement to your process compared to the process capability that you did in the measure phase. Another one, you have to calculate your revised SIPOC at least because your process now has changed. With the new process, you have to showcase the revised SIPOC. Design of experiment. Design of experiment, I will discuss with one example. This is from an automobile organization that one organization, they have advertised with a new car they have launched in the market that this car will give you around this much amount of mileage. But after the customers have bought the car, many of them came back complaining that your car is not giving the advertised standards mileage. So your mileage is not as per the advertised standards, and definitely we are not happy. So in order to make the customers happy, we have to suggest something so that the gas mileage improves. In US, car mileage is called gas mileage. So we asked this organization, step number 2, that what are the factors you feel are affecting the gas mileage? They say that's the speed of the car, the gas octane, that is the petrol or the diesel, and the tire pressure. These three factors affects my gas mileage. Very good. Step number 3, we identified the dependent and the independent variables. Dependent variable, which is the output variable, is the gas mileage, which we want to improve. And the independent variables are the tire pressure, octane, and speed. In any design of experiment, there are two components which you have to remember. Number one is a label. Labels are always two, one minus label, another plus label, and another is a factor. Here we have already seen three factors, so each factor should have two labels. And then we will ask the organization that was with these three factors and the two labels that you have identified for each, please run the car with this combination and then tell us what is your gas mileage that you have got, which I will show you. So the question is, how many trial runs the organization should run? The number of trials as per step number 5 will be number of labels to the power of number of factors. Labels are 2, number of factors are 3. So 2 to the power of 3 equal to 8 trials. What this organization did, when we told them that was for each and every factor, you need to identify two labels. That is 2 tire pressures, 2 octanes, and 2 speeds. These are levels. So they selected 30 and 35 as tire pressure, 87, 92 as octane, and 55 and 65 miles per hour as their speed. So after this, with this combination, we got this data. That is, with this combination of label and factors, they have to run 8 trials. As I said, step number 5, 8 trials. That's why they did 8 trials and gave us the gas mileage. As you see, first they run the tire pressure with 30, octane 87, and speed 55. That's the combination they took. They got 26 miles as the gas mileage. This way they have done 8 trial runs, and these are the gas mileage. This is what we have got. This is our final data which we are going to analyze. In this design of experiment, we need to bring out 2 results. One is the main effect, another is an interaction effect. What is a main effect? Main effect is out of these 3 factors, whether it is tire pressure which is affecting gas mileage the most, or octane or speed. Individually, which one is affecting gas mileage more? That is the main effect or the main result. Another is an interaction effect, that it could happen that maybe not individually, but a combination of 2 or 3 of these factors are affecting the gas mileage more. So that is what also we need to find out. Now, there are 2 tables. One on the left-hand side is exactly the same table which we have done in the earlier stage. Only change, tire pressure column I have marked as A, octane as B, and speed as C. And I have included one column at the end, ABC. ABC means what? A into B into C. So how is ABC for the first row as coming as minus? What is the A column sign? It is minus. So minus into minus, minus into minus comes to minus. Next row, plus into minus comes to plus. This way the plus and the minus are set. Now coming to the right-hand side columns. There are now 4 factors. ABC is the combined or the interaction factor. Now we have got combination of all these 3. So tire pressure, there are 2 columns, plus and minus. Tire, I am getting a value of 25.75 and minus 23.25. How? Tire pressure plus, from the left-hand side table, what is tire pressure plus? It is 35. When the tire pressure is 35, what are the corresponding gas mileages? Let us add up. 27 plus 33 plus 21 plus 22. the average comes to 25.75. What is tire pressure minus? Tire pressure is minus when the value is 30. Against 30, what are the corresponding gas mileages? I add up 26 plus 30 plus 18 plus 19. The average is 23.25. Same way we have done for octane plus minus, speed plus minus, and ABC plus minus as well. So for tire plus minus the minus figure, we get a value of 2.5, octane 3, and speed is minus 9. At this stage, we will check only the absolute values at this stage. So an ABC value is 0.5 or minus 0.5. So which number is the maximum? It is the value for speed. So our conclusion is speed has an important effect on gas mileage. That is the main effect. But how do we come to a conclusion that drive at 55 miles per hour speed to get the best gas mileage? If you see the minus, it is coming as minus 9. That means the minus value is more. And what is minus speed? Minus speed is 55. So we conclude that 55 miles per hour speed is the main effect on the mileage. That is the factor which affects individually. Tire and octane, their numbers are much less compared to speed. So we conclude, and also ABC, that is the interaction, that they don't significantly affect gas mileage. The same exercise we did also on Minitab. So what we did, we selected statistics, the same data we have input. Then with the statistics menu and DOE, we selected the factorial and analyze factorial design. After analyze factorial design, we first selected the factors. We selected general full factorial, and then we selected gas mileage as the response. So these are all set up. After we just confirm once more whether the response gas mileage is set up and the factors are already there. It's the same thing we did qualitatively, we are now doing statistically. So after confirming on this, this is the result if we got. If we see that tire pressure result, for 30 tire pressure, the value is 23.25, and for 35, it is 25.75. That is exactly we get over here. Same with octane. For 87, we got 23. For 92, we get 26. We got a value of 3 over there. Same figure. Now for 55, you see, it is exceeding 28. So we got a value of 29. And for 65, we got a value of 20. Remember the manual figures we did, qualitative exercises? So it is the same figure. So from this picture, it is very evident that for 55 miles per hour speed, we are getting the maximum gas mileage. That is proved qualitatively as well as statistically. Now the interaction effect on the right-hand side, there is no interaction effect. We concluded qualitatively, right? Actually, whenever there is a proper interaction, all these lines should cross. They should interact. There is no interaction. All are moving in the same direction. So we again conclude statistically also that there is no proper interaction effect. Porter's 5 forces. After your improvement is done, your job is not still done. You have to consider some threats before you come out with an improved product or service. There are 5 threats or rivalry which we talk about. Competitive rivalry. This looks at the number and the strength of your competitors. How many competitors do you have? Who are they? And how does the quality of their products and services compares to with yours? When competition is intense, companies can attract customers with aggressive price cuts and high impact marketing campaigns. Also in markets with a lot of rivals, your suppliers and buyers can go elsewhere if they feel that they are not getting a good deal from you. On the other hand, when the competitive rivalry is minimal and no one else is doing what you do, then you will likely to have tremendous strength and healthy profits. Because ultimate aim for any business is to earn profits, right? Next, we will talk about supplier power. This is determined by how easy it is for your suppliers to increase their prices. How many potential suppliers do you have? How unique is the product or service that they provide? And how expensive would it be to switch from one supplier to another? The more you choose from, the easier it will be for you to switch to a cheaper alternative. But the fewer suppliers there are, and the more you need their help, the stronger their position becomes and their ability to charge you more. This can also impact your profit. Buyer power. Buyer power. Here, you ask yourself how easy it is for buyers to drive your prices down. How many buyers are there and how big are their orders? How much would it cost them to switch from your products and services to those of a rival or competitor? Are those buyers strong enough to dictate terms with you? Demanding customers do you have? When you deal with only a few savvy customers, they have more power, but your power increases if you have many customers. Threats of substitution. Threats of substitution. This refers to the likelihood of your customers finding a different way of doing what you do. For example, if you supply an unique software product that automates an important process, people may substitute it by doing the process manually or by outsourcing it. A substitution that is easy and cheap to make can weaken your position and threaten your profitability. Threat of new entry. Your position can be affected by people's ability to enter your market. So think about how easily this could be done. How easy is it to get a foothold in your industry or market? How much would it cost and how tightly is your sector regulated? If it takes a little money and effort to enter your market and complete effectively, rather compete effectively. But if you have little protection for your key technologies, then rivals can quickly enter your market and weaken your position. If you have strong and durable barriers to entry, then you can preserve a favorable position and take fair advantage of it. Difference between Kaizen and Six Sigma. Both are quality initiatives, both are continuous improvement. Kaizen is a quicker continuous improvement, which can ideally be done earliest in 4 days. Approach for a Kaizen is mostly human based, whereas for Six Sigma, we have learned it is improve the existing system in a statistically driven DMAC methodology. Of course, implementation comparatively, Kaizen is simpler and low cost. Comparatively, Six Sigma is difficult and high cost. With this, I come to a close of module 5. Further discussions we will have in module 6. Thank you. Module 6. In Module 6, we will discuss the control phase. Now, in the control phase, we will ideally talk about two major areas. One is the control plan, which is also called an improvement sustenance plan. Another is the control methods. Now, the control plan or the improvement sustenance plan is a plan in which whatever improvements we have done in our improve phase, we try to ensure how do we sustain that. That is through proper monitoring, through proper tracking, how long we will continue based on the impact, based on the quantum of the improvement, we will maintain our improvement sustenance or control plan. The second area that we want to discuss is the control methods. Here I will ideally discuss about three control methods. One is the mistake proofing or error proofing or Pokayoki. Another is the standard operating procedures or SOP, which these two, Pokayoki and SOP, are the qualitative control methods. And the third one is called the statistical process control, which is the statistically done control methods. So first, let us discuss about control Pokayoki. Pokayoki, or in Japanese term, Pokayoki means Poka means mistake, Yoki means proofing. To prove the mistake before it becomes a mistake, that means you have to create your quality control or quality assurance environment in such a great way that no defects would come out of the system at the first instance. That means you prove a mistake before it becomes a mistake. Pokayoki is mostly used in big scale manufacturing organizations. So if you see this particular picture on the right hand side, this is a factory worker with a 3-pin plug in his hand. And there are three sockets on the wall. One 1-pin socket, one 3-pin socket, another a 2-pin socket. Now, do we need to tell this person that boss, your plug will only go into your 3-pin socket? Because in any way, this 3-pin plug cannot go into a 1-pin socket or cannot go into a 2-pin socket. It can only go in the 3-pin socket. So even if the person wants to make a mistake, it cannot make a mistake. That is what is called Pokayoki. That is, create an environment in such a way that no defect could come out of the process very at the first instance. Standard operating procedure talks about written instructions or preparation of procedure for a particular department or business unit or a project on how to set up and run a particular process. It can contain a detailed process, write up with maps, pictures, flow charts, whatever it could be applicable. This should be understood by all the users, or they should be prepared by the people who uses that. Always remember, SOP should be created by the people who do the work and should reflect the best way of working for the entire team so that it benefits all. Use pictures, storyboards, flowcharts rather than text always to describe the process better. There should be a process for updating SOPs on a regular intervals as mistakes are corrected and improvements are suggested. That comes as a different versioning of the SOP. Always the latest version should exist in the market. SOP should be reviewed and approved by the management, especially by people who uses that. SOPs should be verified for accuracy and edited. SOPs should be located where the process is conducted. If it is an HR related SOP, it should be present within the HR team. It should be possibly updated at regular intervals as decided. Clear ownership of the SOP should be established, and always after the SOP is prepared, it is good to have some training in place so that the SOPs are well understood by people, or if there are any doubts or questions, those could be clearly resolved. The third area of control methods is the statistical process control. Statistical process control basically include plotting of control charts with the help of two components, upper control limit and lower control limit, UCL and LCL. UCL and LCL comes out of the improved data that you have. Now you are having an improved data after your improved phase. So you will be coming out with the UCL and the LCL. So your with the improved data, if you plot control charts, it will plot your control limits, upper control limit and lower control limit, which comes out of the improved data itself. And it shows that ideally your data will always reside within the control limits. It should not go above the UCL, fall below the LCL, which indicates that your process after your improvement is done is well under control. Now, Control limits and specification limits. We have already discussed in the conceptual part what exactly are specification limit, upper specification and lower specification limits. These specification limits are given by your customer ideally, where control limits are the tolerance limit which comes out of the process. We will now discuss a few specifically control charts or statistical process control. Let us understand the first example. American Paints wants to determine if the paint production process is in control. Quality of the paint production is critical to ensure highest level of customer satisfaction. Determine if the process is in control. So paint control process, we have, that means it has been improved now, it has been made better. And now it has been made better, we want to check, is the process now under control? So you can understand that this paint control process is a continuous data. And whenever we have a continuous data where there is no mention over here, how many subgroups are being delivered, how many subgroups or how many times the measurement has been done. If nothing is mentioned, we will always consider subgroup as one by default. Okay. Here there is nothing mentioned, only once it has been done. It is very clear from the exercise. And as because it is a continuous data and we want to check because there are no subgroups mentioned, we will do an IMR chart, individual and moving range chart. Whereas if the subgroup sizes are greater than less than 8, we do an X bar R chart. If it is greater than 8, we will do an X bar S chart. Okay. So this is the process of doing an IMR chart from the assistant menu. As you see, we click on assistant, go to control charts, which is the last option, click on IMR chart, specify the data column as the paint control and click on OK. Estimate from the data and click on OK. It will show you on the left hand side, as you can see, the individual value chart and the moving range chart. Both are showing that the data are all within the control limits. That means our process after improvement is very much under control. Now, individual value chart is the individual values, but the moving range, it basically shows the ranges between each and every data point. From first and second data, how much is at the range, second and third, how much at the range. You will see the difference between each value of data. You will find the range over here. The next example talks about Prime Vision Tech wants to check if the number of defects made on a TV production line is in control. All TVs manufactured in a day are tested at the end of the line and the records are stored. We have to check whether the TV defects are in control. So TV defects, this is a whole number data. TV defects is a discrete data. So whenever my data is discrete and we have a count data to do a statistical process control, we do an U chart. So follow this are the steps which you have to do one after the other. I would strongly recommend that when you complete your work, try to get this data file, that is Minitab exercise data file from IMC. You can get it from them. And after getting that, based on the data as shown in the presentation, you can surely do your own practice. Okay. So click on assistant, control charts, U charts, specify the TV defects in the defect column, TV produced as the subgroup sizes column, and estimate from the data and click on OK. Then you see the chart on the left is showing the U chart, that all the data fields are well within the control. Nothing is going out. Only 6 data sets are touching the LCL, which is good. LCL over here is 0, which is good. So it is not going above the UCL. Nothing is falling below the LCL also. The next one we talk about Handsome Tractors Limited wants to check if the number of defective tractors manufactured by a company is in control. We have to check for the tractor's defective whether in control. As because the term is defective, it is a discrete and binary data. And whenever we have a binary data to be checked, we do a P chart. So same way, you see, we go to assistant control charts and we select P chart, specify the tractors defective as the defects column, tractors produced as the subgroup sizes column, estimate from the data and click on OK. Very simple. After that, we will get this data better concentrate on the right hand side where you see all the data points here also are well within the control, no issues as such. Only 6 data points or 5 data points are touching the LCL, which is zero, which is good. So we can say that everything is within our control, no subgroups are out of control. As I said, that for a continuous data, when there are no subgroups mentioned, as we did that IMR chart, we will do an IMR chart. If the subgroup sizes or the number of times the measurements are taken are less than 4 specifically mentioned, we will do an X bar R chart. And when the subgroup sizes are more than 8, we do an X bar S chart. With this, we come to a close of module 6. Further discussion we will have in module 7. Thank you.